Hi everyone, my name is Richard and I'm the Field Engineering Lead for AMPD Energy. And I'm here on behalf of Blue Diamond Machinery to give you an introduction of our product, the AMPD Enertainer. So my company, AMPD Energy, is a Hong Kong-based company that designs, manufactures, and delivers energy storage solutions for the construction sector. Our company designed the AMPD Enertainer with the mission statement, an emission-free future for construction. So our product, the Enertainer, is a lithium-ion energy storage system. It is a one-stop solution that combines not just lithium-ion batteries, but transformers, inverters, and microcontrollers all working together to provide the power that construction sector needs. So our product is comprised of two main parts: an AC side running on AC electricity and a DC side which runs on direct current electricity. And so if I were to cut the container in half here, everything in front would be representing AC. That would be the transformers, the controllers, and inverters. Everything behind me would be running on DC, which is the batteries and the strings. Let's take a look at what the AC side has to offer. So the side the technicians will be mainly interacting with would be on this side of the product. Here we have assembled our many different electronic controllers, each of which would be focusing on a specific part of the circuitry and a specific part of the entire system. So each of these controllers are sending data communication back and forth in terms of how it's operating, what kind of data it is receiving and measuring, and as well how it should be running efficiently. So one of the most important things about having an energy storage system is having a battery management system. A battery management system, a BMS, is in charge of controlling how the battery cells should be charging up, how they should be discharging down, and how it should be balancing all the cells out together. So here we have a system level, or more like a top level, of a BMS controller. Underneath it, what system BMS would be talking to would be string level battery management systems. And those string level battery management system controllers would be talking to individual strings and individual modules or cells about how it should be charging up and discharging down. The system BMS would then be talking to other controllers such as the energy management system, the charger, and on the other side, which would be the power conversion system. So this space right here, typically we would fit a fire suppression system control panel here, similar to what you would get in buildings, where it would be managing the smoke and the heat detectors in the building and to set off in case there is actually a fire. So this is no exception to buildings. In construction sites, there are tendencies of fires to happen, especially with lithium-ion batteries when they overheat. Studies have shown that without a proper battery management system and as well without a proper fire suppression system, you would have fires that could occur. So we would fit a control panel here that would be talking to smoke sensors and heat sensors placed strategically across the room in order to sense if there actually is a hint of fire and to immediately and automatically deploy FM200 extinguishant to put out that fire. So knowing that construction sites are dirty and dusty and overall just a harsh environment to work in, we have designed our Enertainer with air vents so that first of all, it would be air cooling our controllers and circuitry within inside, but as well, we also fit these air filters, which would be placed strategically across so that we would be capturing these dusty and dirt particles to a certain particle size, only allowing. So this is the look of our DC room where we fit all of our battery modules, battery strings, and anything that is within the realm of DC circuitry. Our battery modules, 15 of them are fitted into one column, which we define as one string. Every string will be connected in series. There are a total 8 strings inside this room here, which would be in parallel with each other. The concept of that is if one string drops off for any reason whatsoever, the other strings will continue to run with no disruption. So like I mentioned, it is important that there is a battery management system that is controlling how the batteries would operate. So we have different levels of battery management systems, from the pack level to the string level and as well to the system level. So down here at the bottom of every string, you'll see this white box, which we define as the string BMS. This string BMS will be in charge of looking at all 15 battery modules connected in the string, understanding the voltage and the current and the balancing characteristics of it, and as well managing it so that it will be operating safely and efficiently. So on this side of the product, we have the power conversion system, the PCS. The PCS is in charge for discharging the electricity from the batteries and down to the transformer and back out for the construction site use. So the PCS, we have a rack configuration architecture consisting of 7 different modules in parallel with each other. This parallel connection allows it to collectively provide that 660 amperes of 3-phase power for the construction site use. Just like before when I mentioned in parallel circuitry that if you do have one drop off for any reason whatsoever, is that the rest of them will continue to operate undisturbed. So when we have many different modules all working together to provide that output power, it is important that they are managed very well. And so we do have this subsystem controller as well for the PCS that would be talking to each individual module, understanding how its behaviors are, what faults it could potentially face and what risks it could have, but as well measuring the data for the rest of the system to understand. So right here we have the external human-machine interface. We abbreviate it to the XHMI. It is the interactive control panel that allows the end users to see the behavior and some of the data of how their system is doing. So from top to bottom and left to right, we have 4 indicator lights, each of which would be describing a portion of the system. This light, system, this light, input, this light, battery, and this light, output. And just like any intuitive control panel, green means normal and red means abnormal. So we have 4 of them, we have 3 of them being green, 1 of them being red. The output is red because I still have yet to turn on the output. So if I switch this key position from off to on, it would send that data communication over to the PCS to energize every module to close the circuit and to provide output power. Eventually, when it does become energized, this light will turn to green. The rest of the control panel, we have the 4 columns describing how the system health is doing, how the input is doing in terms of voltage, current, and power, how the battery percentage is, and output power as well, voltage, current, and power. Here we'll show the basic information of the system, but for more of a technical point of view, you get to see more blown up information for it, such as the current per phase, such as the battery voltage and the battery current, such as the power factor and the frequency. You also get to see temperatures of how the system is operating, from the battery cell temperature to the ambient room temperature. Along the bottom side of the control panel, we have home, event log, alarms, and settings. Touchscreen or push button possible, you get to see what events are being logged into the history. As well, you get to see what set of alarms would be appearing here. So alarms would just be the same thing as events, but filtering out all the unnecessary information and providing to you what the actual errors and what the warnings are. On the last page, settings would just show you different changes that you can make to the system, from how bright the screen you want, to how fast you want to charge it, to turning the system on and off, to initializing a sleep mode for it, or changing the language of it. I hope you found it informative, and if you have any further questions, you may reach out to the Blue Diamond team.